Today we are going to learn about mastering recursive feature elimination in Scikit-learn. You'll discover how to implement RFE to enhance the performance of your predictive models by selecting the most significant features. Welcome to our detailed exploration of recursive feature elimination or RFE, a powerful technique used in feature selection to improve model performance. RFE works by recursively removing the least important features and building the model until the desired number of features is reached. This technique is particularly useful in scenarios where the dataset contains a large number of features, some of which may not contribute significantly to the predictive power of the model. Throughout this tutorial, we'll be focusing on how to implement RFE using Scikit-learn, a popular library in Python for machine learning tasks. We'll delve into the step-by-step process of applying RFE, examine its results, and compare it with other feature selection methods. By the end of this session, you will have gained a thorough understanding of RFE and how it can be used to optimize your predictive models.
Feature selection is a critical step in the machine learning process. It involves selecting the most relevant features for use in model construction. The benefits of effective feature selection are manifold. Firstly, it helps in reducing overfitting. Models that are trained on irrelevant features tend to perform well on the training data but fail to generalize to unseen data. By excluding these unnecessary features, we can build more robust models. Secondly, feature selection can improve the accuracy of a model. By focusing on the most informative features, the model can make more accurate predictions. Thirdly, it enhances model interpretability. With fewer features, it is easier to understand how the model makes predictions. Moreover, feature selection reduces the time required to train a model. With fewer features, the computational cost decreases, leading to faster model training. Lastly, it facilitates better data understanding. By identifying the most significant features, we gain insights into the underlying data structure and the factors influencing the target variable.
Recursive feature elimination is a feature selection method that works by recursively removing the least important features and fitting the model with the remaining features. The process begins by building a model on the entire set of features and ranking them based on their importance or contribution to the model's predictive power. The least important feature is then removed, and the model is refitted. This process is repeated until the specified number of features is reached. The recursive nature of RFE allows it to effectively identify the most relevant features for a given model. One of the strengths of RFE is its ability to determine the optimal number of features that contribute most to the model's performance. By analyzing the ranking of features, we can decide which features to retain to achieve the best model performance. In essence, RFE helps in model optimization by ensuring that only the most significant features are used, thereby enhancing the model's predictive accuracy and efficiency. To implement recursive feature elimination using Scikit-learn, we must first set up our environment by importing the necessary libraries. Begin by importing Scikit-learn's datasets, a model such as a linear regression or support vector machine, and the RFE class itself. Next, load a dataset that you wish to use for feature selection. Scikit-learn provides several datasets that are ideal for learning and experimentation. After loading the dataset, choose a model that is suitable for your task. For RFE, you can use any estimator with a coef_ or feature_importances_ attribute. Once the model is selected, apply RFE by creating an instance of the RFE class, specifying the estimator and the number of features you want to select. Fit the RFE instance to your data. After fitting, you can examine the RFE output to determine which features were selected. This output can guide you in understanding the importance of different features and deciding which ones to include in your final model.
Cross-validation is a technique used to assess the generalizability of a model by partitioning data into training and testing subsets multiple times. When combined with RFE, it provides a robust method for feature selection. Using RFE with cross-validation allows us to evaluate the stability and effectiveness of the selected features across different data splits. To integrate RFE with cross-validation in Scikit-learn, we utilize the overfitting class. This class performs RFE in combination with cross-validation to select the best number of features based on model performance metrics. Implementing overfitting involves creating an instance of the overfitting class, specifying the model, the number of features to select, and the cross-validation strategy. Once fitted to the data, overfitting automatically determines the optimal subset of features that results in the best model performance. By using RFE with cross-validation, we can enhance the reliability of our feature selection process, ensuring that the selected features truly contribute to the model's predictive performance.
Once RFE has been applied, analyzing the results is crucial to understanding which features are most important for your model. RFE provides a ranking of features based on their contribution to the model's predictive power. The feature with the highest rank is the most important, while those with lower ranks are less significant. By examining this ranking, you can identify the top features that should be included in your final model. It's important to interpret these results in the context of your specific problem and dataset. Visualizing the RFE results through graphs or plots can further aid in understanding the significance of different features. These visualizations allow you to quickly identify which features have the greatest impact on the model's performance. Armed with this information, you can make informed, data-driven decisions about which features to retain, modify, or discard, ultimately leading to a more efficient and accurate predictive model.
There are various feature selection methods available in machine learning, each with its own strengths and weaknesses. These include filter methods, wrapper methods like RFE, and embedded methods. While RFE is a powerful wrapper method that uses a model to evaluate feature importance, it's essential to understand how it compares to other techniques. RFE has the advantage of considering feature interactions and providing a clear ranking of feature importance. However, it can be computationally expensive, especially with large datasets. Filter methods, on the other hand, are fast and scalable but do not consider feature interactions. They rely on statistical tests to evaluate feature relevance independently of a model. Embedded methods, like lasso or decision tree-based algorithms, perform feature selection as part of the model training process. They are computationally efficient and consider feature interactions but may not always provide a clear ranking of features. By comparing RFE with other methods, you can choose the most suitable feature selection technique for your specific task and dataset. In this section, we will apply recursive feature elimination to a real-world dataset to illustrate how this technique can be used in practice. Let's start by loading a dataset, such as the Boston housing dataset. This dataset contains various features related to housing prices, providing an excellent opportunity to explore feature selection. After loading the dataset, we'll pre-process the data by handling any missing values or outliers. Next, we'll choose a suitable model, such as a linear regression model, and apply RFE. We'll specify the number of features we aim to select and fit the RFE instance to our data. Once the RFE process is complete, we'll examine the output to identify the most important features. These features can then be used to train the final model, potentially improving its performance. By interpreting the results of RFE, we gain insights into the key factors influencing housing prices. These insights can be used to refine our model and make more accurate predictions.
To make the most of recursive feature elimination, it's essential to follow best practices and apply effective strategies. Firstly, choose a model that is appropriate for your task and has attributes like coef_ or feature_importances_ for RFE to work effectively. Secondly, determining the optimal number of features for your model can be challenging. Start with domain knowledge or exploratory data analysis to set a preliminary number, and then use techniques like cross-validation to refine your selection. When dealing with large datasets, consider using a smaller subset for initial experimentation to reduce computational costs. RFE can also be combined with other feature selection techniques for better results. For example, you might use filter methods to quickly eliminate irrelevant features before applying RFE for a more refined selection. Finally, regularly validate your feature selection process by checking model performance on a separate validation set. This ensures that the selected features generalize well to new, unseen data, maintaining the integrity and accuracy of your model.
In conclusion, recursive feature elimination is a robust and effective feature selection method that can significantly enhance the performance of your machine learning models. By recursively removing the least important features, RFE ensures that only the most influential features are considered, thereby improving model accuracy and efficiency. The importance of feature selection cannot be overstated, as it plays a pivotal role in reducing overfitting, speeding up training times, and providing clearer insights into the data. We have explored the step-by-step process of implementing RFE using Scikit-learn, analyzed its results, and compared it with other feature selection methods. With practical examples and best practice tips, you are now equipped to apply RFE in real-world scenarios to optimize your predictive models. Remember, continued learning and experimentation are key to mastering any machine learning technique. Keep practicing and exploring different datasets to deepen your understanding of RFE and its applications.